All right, so yeah, I'm live now. Right, so today I'm going to be uh like my so today is day 15. So yesterday was day 14, right? Let me just confirm that quickly. I didn't really think about that. Yeah, yesterday was day 14. Yesterday made it 2 weeks since I started um streaming. So today is day 15, um week 3, right? And in this week, I'm going to be solving problems related to pointers, right? So let me just confirm my title is actually correct. So I'll just come here quickly, content and live. Yes, so we are going to do two pointers. All right. And before I solve the two pointers question, I actually started working on. I explained a problem yesterday, which is the evaluate reverse Polish notation. It's a medium problem. Let me see how many problem I've solved so far. Progress. Where is it? I only solved two mediums so far. Um, yeah. So today I'm going to solve another medium question, which is related to stacks. Yeah, every other thing is easy. Right. So I'm going to start with okay, so let me close that. All right, so this is a medium problem and it is a stack related problem, right? So, and I tried explaining it yesterday, but I just quickly brushed through the explanation. So here is what I'm going to do today. Yeah, so it has arrays, math and stacks. So this is what the question is related to. All right, so let's go through it without further ado. So I'll just read through the question again. You are given an array of strings, tokens, right, that represent an arithmetic expression in a reverse Polish notation. So a reverse Polish notation is basically an expression where the operands come before the operators. Okay, evaluate the expression. Return an integer that represents the value of the expression, right? So the valid operators are plus, minus, and multiplication sign and division sign. Which operand may be, each operand may be an integer or another expression. The division between two integers always truncates towards zero. So we'll round up the result of our division to a fixed uh, integer without having decimal places. There will be no division by zero. So yeah, there will not be any division by zero. So division by zero is not going to be possible. So they, you know, excluded that in the question. Input represents a valid arithmetic expression in a reverse Polish notation. Okay. The answer and all intermediate calculation can be represented in a 32-bit integer. Well, I didn't put this into consideration, but whatever calculation we are going to do will still fit into a 32-bit integer. We are not going to have like extremely long numbers. So we have here an example. So this is the token. It is in a form of an array with all the operand and the operators in it. So you can see our token is like this. So this is the reverse Polish notation where you see operands before operators, right? And each operator has to act on the operands before it, which is why we have 9 here. So we have 1, we have 2, 1 plus, right? So basically we'll do 1 plus 2 or 2 plus 1. So the second one before the first before the second one, and then we see another 3 again, then a star. So which means whatever result we get here will multiply by 3. So let me quickly go ahead and explain what this is, and just to quickly clarify before I go ahead and implement this solution. So yesterday I started explaining this, and I even used the longer screen, I mean the longer token that we're given. So I'll just use it again, since it is much longer and it will be nice to explain and walk you through the solution. All right, so let me come back here and bring this down. So here we have, now I think I'll start representing my stacks with an actual array, so that it is easier for me to, you know what, let me just stick to representing it the way I normally represent it. So yeah, so here's what we have. So we will not be giving it's just one input, right? Our input is an array. So obviously already we know that this is going to create a time complexity of O of n, which is where n represents the value of the length of this array. So right, so let's start with this. First of all, I would like to use a stack, right? The reason why I want to use a stack is to be able to um, uh, have these operations, right? Like carry out every operation. Like this place now, we have a plus, right? So this is an addition operation on every operand, right? So every operand preceding it has to act on those operand, and it's usually 2 operands at a time, right? And the best way to do that is to use a stack. At least in my own case, to my own understanding, I would like to use a stack to carry out that operation. So I'll represent my stack again, like this, right? That's my stack. I don't have a good you know what, instead of representing the stack that way, I'll represent it with 2 tubes like this with a closed end. Right, so first of all, we want to loop through each of the items in I'll call this, what did I call it here? Token. Yes, it's the token. So here I'll call this token T, right? So now looping through token T, we want to find out which element in the token is an operator or an operand. So here we have, so at this position here, this is 0, right? Position 0, we have 10. So what do? We add 10 to our stack. This will be operand stacks. Operands stack. I'll just call this operand stack. Okay, so this is our operand stack, and every operand we see that is not which is an item that is not a plus, minus, or multiplication sign, or even a division sign, we add it to the stack. So here's what we do. So I'll add 10 to the stack. The next item I see is a 6. So yeah, and at 6, let me just go back and put it here. 6 is 1, so we'll put 6 here. We're at 9, we add 9 to the stack. We are 3. Oh, sorry, jeez. So position 2, the value is 9, so we add 9 to the stack. Position 3, the value is 3, we add 3 to the stack. And at position 4 now, position 4 is an operator, right? So when we see an operator, we want to perform some calculation, right? And to perform those calculation, we need to know which were the last two operands before the operator, right? We want to know which were the last two values preceding this operator here. So this is a plus sign, so we want to do an addition operation on the previous two numbers that came before it. So here's what we are going to do. I'm just going to take let me take by my color. No, let me use this blue one. So this is a plus sign. The last two items were 9 and 3, right? So what do? We insert the operator in the middle. So we do it like this, and then we say operator equal to what? This is 12, right? Then we'll replace the value here by 12, the value at the top of the stack. The first two items we used for our operation, we replace them by the value we got from this place here. So this 9 and 3, right, becomes 12. So we remove 9 and 3 and change it to 12. So I will represent this by a green color to show a new calculation. All right, so that is 12, and then we continue in our stack. So the next number we see here is an 11, a negative 11. Well, this is not an operand, so we don't perform any operation yet. We just add this. This is not an operator, sorry. We don't perform any operation yet, so we add this to the stack. So we add negative 11 to the stack, and we see a multiplication sign, right? This is a multiplication sign. So what do we do when we see a multiplication sign? We take the last two items from the stack, at least the topmost item in the stack, and this is not the last two, but the first two items in the stack, sorry, the first two items in the stack, and we insert the operand in the middle. So let's just go ahead and represent them. So this is going to be 12 times negative 11, right? And this will give us 1 2 1. Let me just be sure. 1 2 1. Calculator. 11 times 12. Oh, 132. Jeez. Why did I say 1 2 1? 132. Anyways, okay, so we have 132 as our value. So it's going to be negative 132 because this 11 here is a negative number. I don't know why I put it there like that. It's a negative number. Let me just erase this quickly. Yeah, so our value is going to be negative 132. Then we replace the values we use for the operation by the answer here. So I'll just take this like this and remove it from our stack, and then I'll represent it with a 1 3 2 like this. All right, so the next item we have in our stack is a division, right? I mean, in our token string is a division. So what do? We again take the last two, at least the first two item in the stack, which is 1 3 2 and 6. So 6 divided by 1 3 2, right? 6 divided by 1 3 2 is going to give us 0, right? So we'll round, it's going to give us 0 point something, right? So we round that value up to the nearest 0. We'll round that value up to the nearest. We don't want to have any decimal, so it's not even going to be one decimal place. It's just going to be 0. So we remove this from the stack and we represent this by the value. So let's remove this from our stack, and I'll put the value we got here. So this is a 0. The next item we see is a multiplication sign, right? So multiplication sign. So first two item in the stack is 10. sorry, 10 10 times, this is our sign here, it's a time, it's a multiplication sign. Sorry, I stopped counting this. This is 5, this will be 6, this will be 7, this will be 8. So at position 8 we have a multiplication sign, so we multiply, we take the first two items in our stack. So this is 10 and 0, so we multiply 10 with 0. Let me change this color again. 10 with 0, and this gives us 0, right? So we replace this value here with our result, which is 0 here. So let's just remove this again, and I'll come here. I'll just put in our correct value, which is 0, right? We have 0 at the top of our stack. So we continue at position 9, right? At position 9 we have 17. So what do we do when we see an operand? We don't perform any calculation, so we just add 17 to the stack, and then we see a plus, right? This is a plus, so we add the previous two again. So previous two, we'll do 0 plus 17, right? And as you can see, I always make sure that I'm dividing I'm adding the first, sorry, how do I say this? The observation here is that I always put the last item, right, in the stack, at least from the first two, right, that we are going to add the, perform the operation on. I put the one before the topmost item in the stack. So 17, 0 plus 17 will give us 17, so we replace this value by 17, right? So I'll just replace both values with 17, and our answer here is going to be 17. Then we see a 5, right? So what do we do when we see 5? We add 5 to our stack, so 5 is going to be here. And the next item we see is a plus. So what do we do when we see a plus? We perform another calculation again. So our stack is going to look like this. Here's what I'm going to do. I just take 17, right? 17 plus is our operator here, plus 5. 5 is the topmost item in the stack, and this will give us 22, and we'll replace the answer here with 22. So we are at the end of our string, so there's no more item to look at, and the value here is what we return, right? This is going to be the final answer of this operation here. And when we look at this, so this is the example we use, and the output is 22, right? Which means it is correct. So that's what we are going to do, and I'm just quickly going to code that. This is evaluate reverse polish notation. I will just use like this. I'll come here and create a new file. So this is going to be my new Python file, evaluate reverse polish notation. And what's the name of 150? So 150, yeah, right. So we are going to start with that, and I'm just going to copy this as as a starter code. And yeah, so what's the first thing we want to do here? Well, like I said, we want to push items to a stack, right? So we first of all need to create a stack. And what do we call our stack? I'll call this operand stack. Sorry, operand. Okay, operand stack, like this. Operand stack, and set it to an empty array. A stack is basically an empty array with values that are arranged from first in, last out. Like, it's just an array basically. So what do we do first? Well, the first thing we'll do is to check, um, is to add an item to our stack, right? And the kind of item we add to the stack is an operator, an operand. Sorry, it's an operand, not an operator. An operand, not an operator. So for us not to add an operator to our stack, we need to have like a, like our operator, um, you know, uh, so here are the valid operators we'll use. So we are going to use plus, minus, and star, and the division sign. Okay. So in order for us to be able to add an item to the stack, because here's what we are going to do. So I'll just do this way. For I in range, right? Range, the length of our tokens, right? The length of our tokens, sorry. The length of our tokens, we want to, we want to add um each item to the stack. So operator operand stack dot append token at I. Now this is valid, right? When we start by this place, let me just come here again. So what I just did is I created a loop that goes through each item in this token here, and I'm appending the items to our stack, right? I'm adding the item to the stack. But the catch here is that we don't want to add an operand to the stack, right? So how do we differentiate the, we don't want to add an operator to the stack. I don't know why I keep switching. Okay, from now on I'll just operand operator, operand operator. So we don't want to add an operator to our stack. We only want to add operands. So here's what I'm going to do. I'll create a list for our operators. So I'll call this operators here. So operators like this, right? And set it to an array of operators. So I'll have a plus, a minus, a division sign like this, and a multiplication. Okay, right, so this is good. Now before I append an item to our operand stack, I need to check if it's not an operator, right? So here's what I'm going to do. If the token at I not in operators, right, then I can do this, right? So let me just go ahead, and print this out to see how it works. So I'll just create a brute solution. I'll call this a solution, and instantiate our solution class here, right? And then what I'm going to do is to print out the solution dot, and I'll just use this test case here. Let's just start with a simple one, right? So I'll just do this. So to be sure that we are not adding any other thing to our stack. So, well, something is happening here. So this is a list solution. Hold on. Oh, I didn't import this. So yeah, now that is solved, and this is here. So I'll just run this quickly. So I'm not printing, I'm not returning anything, but let's say I printed this at the end here. Print what the operand stack here. So we have our operand stack here. Now you can see we only have 2, 1, and 3 without any other operator in our operand stack. So That is step one. So when we see an operator in the stack, right? When we see an operator in our token, so else, what do? We take the topmost items in the stack, right? The first two items in the stack, and then we add them together, and then use that value to replace the position where they were in the stack with previously. So here's what I'm going to do. I'll take the first two items in the stack, right? The first two items in the stack. Yeah, so here's how we're going to take the first one. I'll call this first, sorry, Christ. First first is going to be, you know, the last item in the stack. So I'll just say operand stack minus one. And yeah, let me just do it in one line. First, comma, second, sorry, second, like this, and set it to the second item in the stack. So I'll just do like this, operand stack minus 2. This will give us the second item in the stack. Now, what do we want to do with these two? Well, we want to add the second to, we want to put the second first, the operator in the middle, and then, so I'll just do it like that. I'll just say results. I'll just call this operation result, right? Operation result is equal to second, right? Second and second with, so the operator now will be s at I mean what did you call this, token at I. So token at I, and then we want the first here. Will this work? No, it's not working. Well, what if we do it this way? I'll just say will this work? I think it does, right? This did work, but I'm not sure how reliable this is going to be. This is a concatenation, and I don't want a concatenation. I want an operation to happen. Will this happen if it's, let me just try something here. I'm just going to, print I'll take, yeah, I'll just take it like this. I'll create a new array, and I'll call this, yeah, let me just do operator stack, operand stack, sorry, operand stack like this, and set it to be equal to something like this. No, I'll just use two, 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 and three, right? So we have 2, 3, and so on. Then here's what I'm gonna do. I'll just call this tokens. I don't know why I don't type in very well today. It's weird. Tokens like star. Let me just use a plus. Not to complicate everything, I'll just take it like this, and I'll print operation result just to be sure of what I'm doing. So I'm sure this is going to concatenate and I'll get 23. Yes, this is what's going to happen. We don't want this. We want something like this. How do I do this in Python? Right. Okay, what if this was, okay, what if I transform this to a string, right? String, I mean an integer, and a second and here. Second int, sorry, int first. This is still not gonna work. You can't have stuff like this. So what do I do? Somebody says, suggest me the best resources for DSA or the best YouTube channel. This is the best YouTube channel. I'm just kidding. I mean, I'm not kidding, but yeah, it will become one of the best YouTube channel. The most the most useful place is there's this channel called Neat Code, and you can also make use of uh Greeks Geeks for Greeks or Geeks for Greeks. I don't know. It's a website, and they also have like a YouTube channel as well where they upload you know, DSA questions. Then you can practice DSA questions on um on Lit Code or Hacker Rank or Code Wars. You know what? At the end of this video, I'll just put out all the resources in the description where you can, or I'll just reply you later on. All right. So, um, this is interesting, and if this was like this, then it would have worked, right? This would just go ahead and add this to 5, but there is a catch here. So what do I do? What do I really do to get that value? I want to use my next operator, right, which is plus here. How do I achieve that? How do I get the I don't really know. So let's see. Uh, so I'm just going to put this here. I'm in Nigeria. I'm in Nigeria at the moment. Yeah. So let me just find dynamic operators in Python, right? Operators that can change in Python. So I just had to pass an operator to a Python function. So let's say, hold on, before I look at that, operator gets truth. What does this question say? Turn string into operator. Yeah, that's exactly. I'd like to pass math operator along numeric values to compare to a function. Yep, that is true. Here's my broken code. So here, print, relate true. So here, get truth is okay. Import operator dot gt. Oh, I see. So here, you don't actually need an if statement, right? Get truth, impute, and then cut. Oh, okay. So we. Oh, I see. Let me import the operator module and see what I can do. So we imported the operator module, and I'll say here um, operator, right, dot uh or what did I operator, at token I, like this. Will this work? Nope, it didn't work. I just interesting. Operator dot um so we want to add two items, right? So this is add what did he do here? So this function is uh okay, so relate, then impute operator dot gt. What's gt? What's gt in the operator? Operator dot gt. Gt let me see. Gt operator gt um oh, okay. So this is a callback function. This relate here. You know what? Let me just say we have this function takes the operator in the middle, relate, and then oh, okay. So right. Oh, somebody says why not define your own function? Right. That actually makes sense. I would define a function, but when what I'm trying to do is to be able to use the next operator in the token. So let's say I define a function like this. I have a function. I'll call this a summing, right? Summing. We want uh, you know operand one. I'll call it op1, and then we want the operator, right? Operator, and then operand two like this. So here's what's going to happen. Ideally, you want to do something like this. So return operand one, right? Operand one, and then you want to do operand one, operator, and then operand two, right? But this will not work this way. Um, it will work this way. You can't have three statements going on like this. It's not gonna work. Uh, what if I do it this way? It still won't work, right? So if I say here I want to do something like this, it still won't work. This is not gonna work. It's not gonna work. I don't know. This is just it just skipped my mind. Um yeah, so def add b operators add. So Nah, I don't think that's how I want to do it. Um, let me see. Let me see. Wait, if we had something like this, um, oh, I see. If we had, you know, um, nah, that's not gonna work either. I don't think so. We have, um, why is this messing with me? Oh my god. Um, first, first is the first operand, right? If we have operator, token, token at 0 equals to second, this is not gonna work either. Christ. Okay, you know what? Um, let me just take my time and see what's. Yeah, my favorite place to be. So this is. Yeah, I know we can do plus equal. Yeah, var this is 5, but what if we want it to be dynamic? What if we want it to be dynamic? I mean, this works. Okay, I think I. Nah, that's still a string, right? That is still a string. Um. Oh, okay. I get what. I get this right now. So I'll define a add, a divide, and oh, okay, okay. I see. So here's what we can have, but this should have been straightforward, right? It should have been straightforward, really. So here's what defining functions mean. So I'll just define the functions here. We can have def add. Def add takes, two operands. So I'll just put A and B, and then, right, and then we'll just return A plus B. And then another function, def divide, I'll just call it def, right? Or just divide. Okay, fine. A and B, and then I'll still do the same thing. I'll say, um, you know, return A divided by B, and then another one, um, def, what else do we have? Multiply. I'll do it the same thing. A B. I just wanted something that will be, in a single place, right? Well, I guess this is the only way I can settle for. Return A times B, and then another one, def subtract sub is it subtract. I'll put sub here. Def sub B, A and B. I'll do return A minus B, right? So yeah, this is a suggestion I got from the comment section. Thanks to Steven. Yeah. All right, so we have something like this. This can work, and then what we'll do is have like a dictionary, right? So a dictionary for our operators instead. So we'll have um, operators operators dict like this and set it to be equal to this. So we'll have, you know, a plus sign here like this. It will be equal to the name of the function. So I'll just put add here, right? Oh, okay, I'll just use add like this. This is just going to, let me put it here. I will just remove that. Okay, so this will point to the add function. This is going to be a function, and here we have um, you know, a minus. This is going to be the sub function. We are not calling the function yet. um, then we have, okay, I use a double quotation here, so we'll have a minus here, right? Minus to be sub, and then a division to be divide. So I'll just put div. Did I put divide or div? Okay, divide, not calling the function again, and what else? Multiplication. So here this will be multiply again, right? This this will replace our um operator here. This is actually good, right? I'll just go ahead and use this instead. So let me just remove all of this from here. I'll put it like this. Although this makes the function look a lot longer than usual. So if the token is not in our sorry, yeah, so this is not going to be operator stack, it's going to be operator dict. Yeah, okay, that is good, looking good now. So I'm just going to take these two out, right? So this co I don't know. Oh, it's divided in what divide? Okay, I'll just put what about div like this? Oh, divide, sorry, is division. Divide. Yeah, divide like this. Okay, this is good. Mm. So here's what we're going to do where we see, instead of doing it like this, right? Still, this our operator result. It's just going to be the item, right? So here we'll have an operand. Uh, this one is a little tricky if you don't know. Also thinking about function as a possible variable. Ah, yeah. You know what? Let me just finish with this one first. We'll see. So our operator result is just going to be, yeah, it's going to look weird, right? So we have like you know, the operators dict, right? And we want to choose the current. So we are going to, it's always going to be, you know, plus, minus, and everything. So this will work fine. So I'll just choose tokens at I, right? At I, right? This will return each function. So this is a function like this. I will, you know what? Instead of putting it like this, so you see, it could be divide or anything. Or let's say divide. Let me just take this out. I'll call this function here. Yeah, this is good. Um I'll say operator function, right? Operator function here. This operator function, this dict could be any of this, right? And it will return a certain value to us. Let me see what happens. um so else if the token is at this place, yeah, we already added an attempt to the stack, so we want to run this operation on this. So yeah, so we can say results operation results is equal to the operator function that we got here, right? Let's see what we can do. Wait, what does this return, right? Hold on. Not pair. Yeah, so this add, subs. Yeah, this a function. Yeah, these are functions. So this will return a particular function to us. Then we can use the first and second values here. So I'll put first, no, second before first, second, and then first, like this, right? So this will return a result to us, and we want to replace this result with the first two items in our stack, right? So how do we do that? Well, um, we are going to slice the stack, right? So we'll do something like this. I'll just come back here again. Let me see. We'll slice the stack. So here's what we're going to do. Print. Um, I'll create. I'll just assume this our stack. Let me just use, values is equal to 1, 2, 3, 4, 5, 6. Right. Sorry. And we want to replace the first two. So here's how we are going to do it. First of all, we need to take the first two items, right? We'll slice the array at that point, right? If we do something like this, value um 2, I mean -2, we want to use -2, -2 -2 going down, right? So this will give us 5 and 6, right? So it means we are starting from -2 all the way down. But if we did something like this, we put it here like this, it will take every value except for -5 and 2. And this can still work, right? We can do something like this, except in this case we have to replace the value of the array. Yeah. Well. -5 and 2. We take this and we append our values to it. But then we have to replace the stack by the value in the stack. Or if we did something like this, so I'll just do it outside here. I'll do results, right? Who is here? Okay. So it's okay. Nobody asked anything. Emmanuel is here. Anyways, that's good. So I'll just do res for results, and then I'll take the last two items in the array. So I'll just do var and negative. So I'll start from -2 down, right? Or the best way is to just do it this way. So I'll just take the first items except the last items, right? I'll take them and say value um hold on. Why am I confusing myself? So this returns our first item, but the last two, right? This will be the top item in our stack, the first two items. So we want to replace their value, right? So here's what we're going to do. If I slice an item from the stack, from an array, what happens to the array? Right, let me just, the array still remains the same, so I want to replace it in place. So this here, right, I can do something like this, right? So this two item should be equal to, let's say it's equal to 12, right? So what's going to happen? Okay, I can only assign an iterable, so let's say 12 like this. So it's putting it at the beginning. I don't want it at the beginning, I want it at the end. So here, so yeah, we've successfully replaced this. Okay, this works, this works. So here's what I'm gonna do. This will be our result here. So I'm just going to take the first items in the stack. I'll just do the first two items in the stack, right? So operator stack or operand stack, what did I call it? What's the name? Operand stack. Okay, operand stack. Yeah, the last two items are going to be replaced with our, you know, operation results here. Okay, so this is what we are going to do every time we add an item to the stack. I'm just going to print the stack now and see what's inside, you know, just to be sure that this actually works the way I tell it to. mm, yeah, so let me just go ahead and do this, right? I mean, I didn't even need to put this in the print function. I can just put it like this and it will print it for me. So, oh, okay, right, I know why this is happening. Can't multiply sequence by non-integer type string. So what's happening? Do we, you know what if we do int a and then int b, right? So here I'll just copy a and b like this, put it here like that. I'll just bring this back to the subtraction here, to a division, and here back to, what's this, addition plus. Where's my plus? Okay, yeah, how about now? Okay, can only use, oh sorry, here, I needed to put this here. Okay, so this works. We have 9. Yeah, this actually works. This is 9. This is the result here. So the only thing I need to do at the end of the day, because we want to return an integer, this function expects an integer as the resulting value. So here's what I'm going to do. At the end of the day, we are going to have like one item in the stack, but just to stay on the safe side, right? I can do this return. Where did I define the operator? Operand stack, operand stack, right? We want to return the, the only item in the array, right? This will work. This will return 9. I've already returned before printing. So let me just move this to the top again. I'll remove this from here and just put it at the bottom. Yeah, and also so that I can see the value here, right? So let's just go. This is 9. This actually works. This is the value 9 here. Uh, no questions. Yeah. I don't know who Steven is, but I would appreciate if Steven uh, can, message me on LinkedIn. Um, I'll drop my LinkedIn link in the description. Oh, my time is almost up. Wow. I didn't even start whatever I set out to do today. So I'm just going to use another 30 minutes. Christ. Time is just running, man. Yeah, this operation sort of works, but you know, there's always the lit code catch. I mean, let me test it with a second case here. Instead of testing like that, I'll just okay. Don't be lazy. Let me just come here. I'll copy this again, right? Oh, there is. Ah, I see. I mean, what if we had like an A or X in the string, right? This is going to work for this case here. This is fine. But like, this is 22. But like, what if we had like an A or a B in the string? Do we need to account for those as well? It ignored it. Wow. This is not supposed to happen. We should have 22B in this 22B, but B does not have any operand in following it, right? So let me say I have a plus here. Okay, operator here. So plus. Aha. This is where it becomes tricky because normally we should have like 22B at the end, but this is not what is happening here. Well, so these functions here would need to have some edge cases, right? Especially these ones. I'm not sure they are going to add a division with a letter, but like stuff like this, minus and multiply, all of those things. Well, I also need to check for that. If the operator can be converted to an integer, right? Then we can make it we can just run a concatenation on it, right? So yeah, in this case we'll have like 22 plus b, right? 22 plus b instead of this error that we are seeing here, because you can't convert b here to um, an integer. It's not gonna work. So what do we do in this case? And which one do we even know is going to be the operator? Or let me just check the constraints here to just be sure, right? What does the constraint say? Okay, it's always going to be an integer. So or an integer in the range of, okay, it's not going to be, all right. I was just disturbing myself then. So we are good, right? Let me just remove this. We are good with this. This is okay. But the division, right? The division says we should round it to, um, a fixed decimal place, right? So Let me see. If I had something like this, print do we have, round 0.333, right, to just one, right? How many would it give us? Oh, we don't want any, so just round it up. Yeah, so this will give us 0. Yeah, that's good. So that's what we want. We just want to round this at the end of the day. Although we didn't round this, right, it still worked, but because we had the multiplication in it, we don't even need to round it. This actually works. But yeah, just to be safe, right, I'll just put round here and run this function again. We have 22. Let's go to lit code and see what lit code has to say. I'm just going to remove this. Although this might seem a bit complex, but the only complexity here is, the custom function for the operation. Otherwise, it was quite straightforward. Here. So let me run this here. Our test case is here. Oh, there is a wrong answer. Okay, this is interesting. So what's the, we have expected, it got 7. Why is that? So we'll add this to the stack, division, and then what's happening here? We added 4 to the stack, 13 to the stack, and 5 to the stack. But when we saw a division, we divided 13. We'll divide 13 by 5, right? Wait, are we rounding it up and not to like a fixed decimal place? Are we rounding it up? Because 13 divided by 5 is what? Let me see. 13 divided by 5. 2.6, which means they've rounded this up to 3, right? So I've forgotten this thing to round up a decimal number, decimal in Python. Oh, I don't want to import any built-in function. What's this? Round. Meaning round should have given us the value, right? So 3.7. Really? But we can see math cell. Oh, okay. We can use math cell. So math cell. I know math cell. Let me see. If I did this, let me just remove all of these stories from here. You know, I'll just take print. Although we need to import math, so math seal, right? Seal. Oh, come on, seal 2.7. What will you give us? It's 3, but what does math around do? Rounding, print round 2.7. What would this do? This is also giving us 3, so why is, wait, is it rounding them individually? Nah, this is not supposed to happen. You know what? Let me just take my divide function here and operates operation. This is impossible. We don't even need to return a difference. So divide print divide divide 15 I mean 13 and 3, 13 and 5, sorry, 13 5, right? So this should give us 3. Yeah, the answer is 3. So what is this code saying? I got the answer wrong. Are you kidding me? This is not possible. This is not possible. Let me come back here and see what is wrong with this solution. Why are you still printing 3 now? Okay, I know why. So I want to see my answer. Print operand stack operand stack 0. I don't need these anymore. I don't need those anymore. I just need this. It's giving me 7. And what did Let's Go say? I gave. The answer is 6. How? How is this 6? I mean, there's division before the plus, right? So how come? Why is this? I don't get it. This is strange. Strange things from Let's Code. Very, very strange things. Why is this going to give us? Wait, are they doing? Yeah, no. I mean, 13 by 5. This will give us 3. Oh, wait. Oh, they are rounding down. Oh, okay. Round down. So, okay. I get it. So it's not rounding up, but floor, like using the. I see. Instead of math seal, right? It's going to be math floor, right? Math the floor. I think this will work. Math the floor, and then let's do it this way. So this is going to give us 2. Um, can we import built-in functions in you know in Let's Code math.floor? And what are the implications? Is it going to like increase? So you can see we have 6 here instead of 7. Is this going to increase like? Okay, it works. Import math, right? So we're going to use math.floor. So it's not going to be round, but it's going to be math.floor here, right? And let's see. What? No way. What happened here? Why is this 2020? Why is this 12? So the division is just the problem right now. That's crazy. I mean, what's the worst thing that's happening here right now? Um, I mean, I saw this before, right? Nobody in the stream. Or did he? Right, so I'm just gonna try this out again and see where the issue is coming from. Honestly, these are just strange stuff. Why do I have 12? What's happening? Why do I have 12? Let me print my. Why do I have 12? Yes. Oh, wait. Oh, no. No way. You know what? Round again. And you see, this is supposed to be 0 and not 1 negative. Because the value of this division here is 0. This negative 3 point whatever. When you divide it, it's supposed to give you 0. Mat the floor, right? Mat the floor 6 divided by 132. Sorry, let me just remove this from here. This is not fair. Why is it? Yes, it's 0. So, I mean, so why was it doing mat the floor? Okay, so a negative number, right? Negative this. Oh, so now it's negative 1. Interesting. Um, well, when it comes to okay, I mean, how do we convert a negative number to a positive number? Mm, mm, mm. Okay, so we want to use the absolute value. Okay, ABS. I mean, can we use ABS on any number, even if it is positive? ABS of S, absolute value. Yeah, it works, right? But what if it's is like this? It still works. So in division, we want to do mat dot floor, but then we also want to mat dot floor uh, absolute value after the integer. So ABS integer. I mean, if it's negative value at the top, we don't really mind. But when the denominator is negative, it's going to give us an unexpected value. So yeah, Let me just go ahead and do this. This works now. Just fixing, one part of the code from one part to the other. Mother floor. Okay, so here, let's run this again. I'm sure this is gonna work. Yeah, so the three cases have passed, but we this doesn't mean the submission is going to work. But let's just hope. Okay, you see, it's not valid. It's even 23 over 21. Um, 18 is not valid by expected return type. What's this? Oh, what am I? What? What's this saying? It's not valid value for expected return type integer. Wow, what's happening? We had 18. These are very, very strange cases, but let's see. Um, 18. I mean, it's going to be any value, so that also works. Why did it? Wait, type error. Okay, I know. Right, you're worried about this. No problem. So this is going to be int, right? Is that okay? Well, it's still, I mean, it doesn't matter, but let's give it. Oh. Output negative 3 and expected negative 7. What's happening here? So we have negative 2, but the division here. Oh, so the absolute value now is now affecting this. I mean, the 4 divided by negative 2 should give us negative 2. Yeah, that should be negative 2. But this is not working because um negative, because I just did the absolute value there, which is not supposed to happen. So what am I supposed to do? Negative 4, negative 5, negative 6. Where's my calculator? Ouch. Okay. I was, you know, expected to solve this question in like 30 minutes, but now it's like 1 hour, 30 minutes. And My time has elapsed and I couldn't. Negative 2, 4. Okay, the only time we can return negative 2, I mean, we can do this absolute value thing here. So, wait, so 4 superior to 7, right? So let's say I divide 2 by negative 4. This is supposed to give me, a 0 0.2. Okay, so here's what I'm going to do. If the b is superior to a, no. If absolute of b is superior to a, yeah. If absolute of b is superior to a, so abs, absolute value of int b is superior to a, right? Then I want to do this. Otherwise, I just want to uh, do the division like this, right? So, yeah. Oh, integer a, sorry. Int a, alright. What? This 12 again. Oh, sorry, return. Return. Return this. Okay, that worked. Let me see this one. Oh, now I give up. Honestly, these are like really strange cases. I mean, I can't possibly go through all of this now. Um, I'll have to come back to this question again. This like two questions now that I said I'll come back to, and I definitely will. So let me put my LinkedIn profile here. I'll just take this linkedin.com. So yeah, here's my profile on LinkedIn. Alright, I'll put this here in the description. Yep. Right, so that's my LinkedIn. If you want to contact me, you can reach me on LinkedIn. Let me share. Share profile. Okay, so here there's my LinkedIn profile. Save. Okay. I think I'll need to close for today. Honestly, this is a horrible fail, but you know, if there was an editorial, I would have gone through the editorial, but the editorial is locked, which means I'll have to solve this. But there is solution panel where a lot of people, tried out their solution. But I'm not just going to look at it now until I get my own answer. Then I can refer to it. But there is no shame in looking at, the solution, right? There is no shame in it. It's just part of the learning process. You can still look at the solution, but just make sure you understand the solution well. I know my solution will work. I mean, that might sound a bit cocky, but yeah, it's just something I have in mind. But I will still look at what I'm possibly doing wrong. I'm sure the custom calculation here is killing my implementation of this solution. But yeah, we we continue tomorrow. All right.